Think traffic is the worst part of your day? Now imagine skipping it completely, lifting off the ground and moving above it all. What you're about to see is not a concept, a render, or a distant dream. This is real technology being developed right now in China, where next-generation flying vehicles are moving from testing into real-world use. From compact eVTOL aircraft built for city travel to advanced flying platforms backed by massive investment, in this video, we're breaking down the most advanced flying vehicles, the technology behind them, and why they matter not just to engineers, but to anyone tired of being stuck in traffic every single day. Stay tuned, because what you're about to see could completely change the way you look at travel forever. Forget everything you know about vehicles, because this one does not just drive or fly, it switches between both like it belongs to a completely different era. The Xpeng AeroHT X3F, developed under Xpeng AeroHT, introduces a modular design where the air module detaches from a six-wheel ground carrier known as the land aircraft carrier, instantly transforming from a road vehicle into a two-seat electric vertical takeoff and landing aircraft. The ground carrier is not just transport, it carries, protects, and charges the air module when it is not in use. When it is time to fly, the module separates and operates independently, ready for quick aerial missions. Performance is built for speed and efficiency, with estimated flight speeds between 186 and 224 miles per hour. It offers a flight time of about 20 to 35 minutes per charge, making it ideal for short, time-sensitive travel. Under the surface, it uses 8 electric motors, 6 dedicated to vertical lift through propellers, and 2 ducted fans for forward and backward movement. This setup enables smooth transitions between hovering, climbing, and forward flight with strong stability and control. Inside, the cockpit features a 270-degree panoramic design, giving both pilot and passenger a wide field of view for better awareness and safety during flight. Control is highly advanced, offering dual modes. Autonomous mode handles one-touch takeoff and landing, automatic route planning, and return-to-home functions, while manual mode uses a single-stick joystick with comfort and sport settings for precise handling and responsiveness. What if crossing entire cities felt less like a journey and more like a smooth, quiet flight above everything? That is the idea behind the EHang VT35, developed by EHang, an autonomous long-range electric vertical takeoff and landing aircraft designed to connect city clusters through real-world aerial travel. Built on a lift and cruise configuration, it uses vertical lift for takeoff and landing, then transitions to efficient forward flight for cruising. This balance allows it to operate with both flexibility and extended range, making it suitable for intercity routes, cross-sea travel, and mountainous terrain. The VT35 delivers a design range of at least 124 miles and can stay airborne for up to 60 minutes. It cruises at a minimum of 134 miles per hour, combining speed with efficiency to handle longer routes without compromising stability. With a payload capacity of 441 pounds, it is designed to carry 2 passengers plus luggage, making it practical for regional mobility. Its propulsion system includes multiple lift propellers for vertical takeoff and a rear pusher propeller for forward motion, enabling smooth transitions from hover to high-speed cruise. And with a fully autonomous flight system, there is no pilot on board. Navigation, control, and safety are all managed through advanced onboard systems supported by centralized monitoring. EHang VT35 is a clear step toward autonomous air travel becoming a practical reality, reshaping how people move between cities. What if racing left the track behind and moved straight into the sky, machines slicing through open air at unreal speeds? That's the vision behind the Airspeeder Mark III, the world's first fully functional electric flying racing car, developed by Zapata Aeronautics in Australia. At its core, the Mark III is engineered for raw performance. Its electric powertrain delivers between 96 kilowatts and 320 kilowatts, creating an exceptional power-to-weight ratio that drives explosive acceleration and sharp aerial control. It hits top speeds between 75 and 100 miles per hour, but what sets it apart is its ability to maneuver with precision, not just speed. Acceleration is instant and aggressive, going from 0 to 62 miles per hour in just 2.8 seconds. That performance is backed by an ultra-lightweight structure, weighing between 220 and 287 pounds. It's allowing maximum efficiency, responsiveness, and agility during flight. Every detail of the Airspeeder Mark III is built around one purpose, bringing the intensity of elite motorsports into the sky. Fast, responsive, and built for competition, it marks a bold step into a future where racing is no longer limited to the ground. What if stepping into a vehicle no longer meant taking control, but instead trusting a system so precise it pilots itself and flies you to your destination without a single manual input? That is the EHang EH216-S, developed by EHang, a fully autonomous electric vertical takeoff and landing aircraft and the world's first pilotless air taxi to receive type certification for commercial passenger operations. There is no pilot on board. The EH216-S operates as a fully autonomous air taxi, following predefined routes while being monitored by a centralized command and control system. Every flight is tracked and managed from the ground, adding oversight while removing the need for human control. Designed for short-distance urban travel and aerial tourism, it reaches a maximum speed of 81 miles per hour and cruises at about 62 miles per hour. Its range is focused and practical, offering between 19 and 22 miles per charge, with a flight time of roughly 21 to 25 minutes, ideal for quick point-to-point trips that bypass ground traffic entirely. Despite its compact mission, it delivers solid capability, carrying a maximum payload of 220 kilograms. Charging takes about 120 minutes, allowing for efficient turnaround in commercial or tourism operations. It can operate at altitudes up to 3,000 meters, staying well above urban obstacles for smooth, elevated travel. What makes the EH216-S stand out is its purpose. It represents a shift toward fully autonomous air mobility, where the aircraft, control system, and infrastructure work together to deliver safe, efficient, and fully self-managed flight for the future of urban transportation. Picture stepping into a machine that feels like a sports car, then lifting straight off the ground, quiet, smooth, and fully controlled in the sky. That is the Jetson One, a single-seat, all-electric vertical takeoff and landing aircraft developed by Jetson Aero. Designed to feel intuitive and approachable, it is often described as a personal Formula One car for the sky, built around simplicity, safety, and accessibility. As an ultralight class vehicle, it may fall under regulations like FAA Part 103 in the United States, allowing operation without a pilot's license in certain cases, which significantly lowers the barrier to entry. Performance is intentionally limited for stability. It reaches a top speed of 63 miles per hour, with onboard software controlling output to keep handling predictable and safe. Horsepower comes from 8 electric motors, producing a combined 88 kilowatts. Each motor drives its own propeller, creating a distributed propulsion system that improves lift, stability, and responsiveness. The system is powered by high-discharge lithium-ion batteries, engineered to deliver the rapid energy needed for vertical takeoff, hover, and controlled flight while maintaining a lightweight structure. Flight time averages around 20 minutes with a typical pilot weight, making it suitable for short-range, controlled personal flights. Safety is where it truly stands out. A triple redundant flight computer continuously stabilizes the aircraft, and if the pilot releases the controls, it automatically maintains a steady hover. Priced at around $98,000, the Jetson One sits at the intersection of advanced aviation and personal transport, bringing controlled flight closer to everyday reality while still requiring strict training and safety standards. What if you could strap on a machine and actually take flight, feeling every movement, every shift in balance, like the sky responds to your body in real time? That is exactly what the gravity industry's jet suit delivers. Invented in 2017 by British entrepreneur Richard Browning, this is the world's first patented body-controlled jet-powered suit, built to merge human instinct with real aerospace engineering. At its core, the suit uses 5 to 7 miniature jet turbines, with 3 mounted on the back and additional units on the arms. Together, they produce over 1,000 brake horsepower, generating enough thrust to lift a person straight off the ground and into controlled flight. The performance is just as intense. It can reach speeds of up to 85 miles per hour with a flight range of about 5 kilometers. Each flight typically lasts 5 to 10 minutes, powered by kerosene, diesel, or Jet A1 fuel, making it ideal for short, high-intensity bursts where precision matters. What sets it apart is the control system. There are no joysticks or cockpit controls. Everything is managed through body movement. By adjusting arm positions and shifting balance, the pilot directly controls thrust, creating a flight experience that feels natural, like skiing or surfing, but in the air. Structurally, the suit is built using advanced materials like aluminum, titanium, and high-performance polymers, often produced with 3D printing to keep weight low while maintaining strength under extreme forces. This system can reach altitudes of up to 12,000 feet under the right conditions, and placing it firmly in the category of extreme personal aviation and redefining what it means to fly. What if your commute didn't depend on roads, airports, or even traditional flight paths, but instead, you could lift off and choose your own route through the sky? That's the idea behind the XTI TriFan 600, a high-performance vertical takeoff and landing aircraft developed by XTI Aircraft Company. At its core is a hybrid electric propulsion system, where a fuel-powered engine drives electric fans to deliver strong, efficient performance while reducing energy waste. The TriFan 600 can reach speeds up to 345 miles per hour and cruise between 25,000 and 29,000 feet, allowing it to fly above weather and congestion for smoother, more efficient travel. Its range highlights its versatility. In vertical takeoff mode, it can travel around 600 to 700 miles. With a conventional runway takeoff, that range extends to about 1,200 miles, giving operators the flexibility to prioritize either convenience or efficiency depending on the mission. Inside, the aircraft is built for comfort and privacy. The pressurized cabin supports high-altitude flight and accommodates 1 pilot plus up to 5 passengers, making it ideal for executive travel. The design uses 3 ducted fans, 2 on the wings and 1 in the fuselage. All 3 generate lift during vertical takeoff, then the wing-mounted fans rotate forward to transition into high-speed forward flight. This seamless shift between vertical lift and efficient cruising allows the TriFan 600 to operate from tight spaces like helipads while still benefiting from runway efficiency when available. Imagine standing on what looks like a futuristic hoverboard. No wings, no runway, no cables, just pure thrust lifting you into the sky like gravity suddenly gave out. That is exactly what the Zapata Flyboard Air delivers. Created by French inventor Frankie Zapata, this is a fully untethered, jet-powered personal flight platform built for real-world performance, not just demonstrations. At its core, the system runs on 5 miniature jet turbines, each producing around 250 horsepower. Together, they generate the thrust needed to lift a pilot and maintain controlled flight, delivering raw power in an incredibly compact form. And the performance is where it really stands out. The Flyboard Air can reach speeds between 93 and 118 miles per hour, putting it in the same performance range as high-speed aircraft. It can also climb to altitudes of up to 9,800 feet, taking personal flight far beyond typical recreational limits. Flight time is limited to about 10 minutes, driven by its kerosene fuel system carried in a backpack. The system supports a pilot weight of around 220 to 225 pounds, maintaining a carefully balanced thrust-to-weight ratio for stable and responsive handling in the air. What makes it even more impressive is how it operates. There are no traditional controls. Stability and movement are managed through advanced onboard systems and pilot balance, making it feel like you are directing the machine with your body. This platform has already proven its capability. In 2019, it successfully crossed the English Channel, and earlier, in 2016, it set a Guinness World Record for the longest hoverboard flight, covering 7,388 feet. These milestones helped push the Flyboard Air from a bold concept into a proven piece of personal aviation tech. And just like that, the future of travel doesn't feel so far away anymore. What you've seen today isn't imagination. It's the beginning of a shift that could completely redefine how we move, how we build cities, and how we experience distance itself. Flying vehicles are no longer a question of if, but when, and the pace of innovation is only accelerating from here. If you found this as fascinating as it is powerful, make sure to hit that like button, share this video, subscribe, and drop a comment below telling us which flying machine you would trust to take your first flight.